Hello guys, welcome back to another video. Today we're going to be going over the derivative function, probably the most important lesson you'll have in your whole entire calculus career. This is going to be amazing, guys. So last video we already went over tangent slopes and rates of change and how you can analyze a function to find its tangent slope. So if I have this function, right, and it's like this, I can find the tangent slope here, 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 and analyze the slope of a particular point on this graph at any little given point. However, we haven't learned how to do that yet. What we have learned how to do is find the slope using our rate of change formula, but this time we're going to learn how to use the slope, how to figure out the slope of the tangent line by the derivative function. Okay, so if I have f of x equals x squared, our most simple function. We're going to leave that there, and I'm going to graph it for you right here as well. Let's graph this function like that. There's our f of x, x squared. Now let's talk about the derivative functions. What is the derivative function? The derivative function is this. M tan, we're going to label it M tan because it's going to give us the tangent line slope. Slope of our tangent line equals, now here's the function, write this down. Limit, we're going to take the limit, these never go away, h, as h goes to 0, of f of x naught plus h minus f of x naught all over h in brackets. So this is going to give us our slope. We're going to save that there, actually. I'll leave this up here so you can reference it. And we're going to scroll down here. So we already know our function. We're going to try this with the function f of x. Not even going to show you the graph yet. Equals x squared. Go ahead and pause the video and see if you can plug this in and see what happens. I'm going to show you how right now. So this x naught plus h is really f of x, right? We're going to plug it in to f of x. So we're plugging in x naught plus h into our f of x function. And we can replace this with this whole f of whatever. And then here, we're going to do the same thing. So let's plug it in like normal. We have our function f of x. This is f of x. Let's plug in x naught of h, x naught plus h into our function f of x. So we're going to keep the limit. M tan equals lim h goes to 0 of, plug it in, x naught plus h, plug it into this function, right? We took this as our x value and put it in and substituted, and we're going to do the same thing here, which is going to give us minus f of x naught squared, all divided by h. That does not change. And there is our function. Also, before we start this, we're going to actually define our h variable. You might be wondering what h is. H is x minus x naught, right? Because it's measuring the sort of gap that you have between, see, if I have this function, this parabola, right? And I want to find the tangent line here. I have this tangent line. And then this is the secant line that follows the actual function. And then I want to measure like the distance between these two. So it's going to look something like this. This is x naught. And then this would be, right, like 2, or whatever we're trying to plug in. So this is our actual x value. This is going to be x, right? So x naught minus x is actually like, there's a little tiny rate of change right here, which we're setting equal to h. So that's where h variable comes from, which may help you understand why we're actually doing this with an h. So let's evaluate this when x equals 0. So we're going to have the limit as h goes to 0 of, let's plug in our 0 plus h squared minus 0 squared over h is going to come down to be m tan equals the limit as h goes to 0 of h squared minus 0, or we can just call it 0, over h. This cancels out, and this is going to leave us with m tan equals the limit as h goes to 0 of h, which is just going to be 0. So we found our tangent slope when x equals 0, because if you think about it, this is where the graph comes into play. Our function is just this, x squared. No shifts or dilations. So when our limit approaches 0, what's this slope? 0, right? It's flat. So as this comes 0 from the right, from the left, our tangent slope comes in. Our tangent slope is now 0 at this point, which is how we got 0 as our slope. Now let's do one more example. I'll have you do it on your own. I'll set up the function. Actually, I'll just give you the function and then ask you to find the tangent line of that particular point, and you're going to use the formula by yourself. So, if I say y, or better, f of x, equals square root of x, and then I want you to find the slope of the tangent line when x equals 1, when x not equals 1. Go ahead and do that and see if you can figure out how to do this on your own using the function we just learned. Okay, so I'm going to go ahead and do it now, very quickly. So if we have, I'm not even going to write m tan, I'm just going to say, I will, m tan equals our limit as h goes to 0 of x naught plus h squared minus x naught squared over h. Now let's go ahead and plug in our x naught right away. Let's go ahead and plug in our x naught right away. So then we can get m tan to be equal to the limit as h goes to 0 of, finding it when x equals 1 plus h, 1 plus h squared minus 1 squared, oops, let's try to differentiate it using this color, over h. Simplify. Our m tan equals the limit as h goes to 0 of 1 plus h. I'm going to get rid of the color now. 1 plus h. 1 plus h minus 1 squared over h. And then we're going to have, this is going to be equal to the limit as h goes to 0 of, let's factor these, combine these terms. 1 plus, that's going to be 2h in the middle, plus h squared, minus 1, right, because this is in parentheses, all over h. Now, do the same thing, our limit as h goes to 0 is going to be, oh look at that, it's perfect. This cancels out, and we're going to be left with simply 2h here. Let's just factor out the h right away, h, so we can factor it out from here. We got 2 h's, so it's going to be h, and then we're going to have 2 plus h, all over h. Look at that, our indeterminate function comes out perfectly, and we just have our limit as h goes to 0 of 2 plus h, which is going to be lim h goes to 0 of 2 plus 0, which equals 2, and that is our m tan for our, this is a cubic root function, right? Cubic root, like that, when x equals 1, or y equals 2. And that's exactly what would happen if you plugged it in, our slope equals 2. And that's exactly how you find the m tan of any given function using the derivative formula. So thank you guys for watching. If it really helped, make sure to like, subscribe, and leave a comment for next time. Bye.